in this video, I will model a 20-year level debt service municipal bond structure, and we'll do that using some tricks that are specific to municipal bond structuring, but also we'll try and use some good spreadsheet practices that everyone should follow in building spreadsheet models. So here we are. We're in Excel, and I don't like grid lines, so I'm taking those off. And the first thing we're going to do here is set up a sources and uses of funds. And our sources are going to be par amount and plus premium or minus discount. And if there was an equity contribution from the borrower, then that might go in here. But those are going to be the three lines that make up our sources. You've got the par amount of the bonds. If there's a premium or discount, then that'll be either added or subtracted. And then if there's an equity contribution from the borrower, that would go here. But our total sources will just add up like that. On the uses front, we're going to simply have a project deposit, and the other use we'll have a contingency or rounding amount, which will come into play when we ultimately solve for our bond size. Sorry, you know what? We're going to add one other use here. Cost of issuance. And for our purposes, we're just going to have that be 1% of the bond size. And so our total uses are going to be that. And let's say our project deposit is, we'll just format this, 100 million. And that will be what we're financing. Could be a $100 million bridge, could be a $100 million road reconstruction, could be a hospital, anything that qualifies for tax-exempt financing. And the other thing that we're going to need, for purposes of coming up with the debt service structure, we will need a debt service amount that will be paid by the issuer annually. This is ultimately a number that will be determined in a way that is sufficient to generate enough proceeds from our sources, from our par amount of bonds, our premium discount, and our equity contribution, and we're going to make that equity contribution 0, to satisfy the uses that we have here. And our cost of issuance is just going to be 1%. We'll call this cost of issuance percent, and we're going to multiply that times par. Of course, we didn't define par. Par is right here. Now, our debt service annually, we don't know. Let's make this a 20-year debt service deal, but our debt service annually, let's say, is $10 million. I don't know if that's going to be sufficient. We're going to find out in a second. Now, from here, what we need are some time periods in order to calculate debt service payments. Debt service, of course, is principal plus interest. And so down here to the right, let's just say we've got 20 years worth of debt service to deal with. And let's call this annual debt service. And so our columns here, we're going to have year, principal amount in each year, coupon, interest, payment, the dollar amount itself, and then we'll have debt service, which if this is A and this is B, then this is A plus B. So what are our principal amounts? Well, we're not sure. We know that we've got this annual debt service to work with. Let's first put in our coupons here, and I have already grabbed some numbers from a recent financial publication that has values in it for our coupons. And we're just going to assume for simplicity's sake that our coupon is equal to the yield, and these are all par bonds. Now in reality, coupons are going to tend to be in 5 basis point increments. And on the long end, for a number of sort of technical reasons we won't get into in the municipal market, you would probably likely have coupons that are higher than current market yields, so 4 or 5% coupons. And that would ultimately lead to premium bonds, so there would be some premium to put in that sources and uses. But for simplicity's sake and what we're doing today and in this model, we're just going to use these rates, these yields as coupons, and therefore assume par bonds. So what is our interest formula here? This is a question we ask people in interviews, by the way. So if you're starting out in your career, take note, get that out there. But if we know our principal amounts are here, let's just put in some principal amounts. How would we generate the interest payments for this principal? Well, if you've never looked at a schedule like this before, this means that the interest payment calculated here in year one, at the end of year one, is going to be $10 million at 27 basis points, plus $10 million at 45 basis points, plus $10 million at 65 basis points, all the way down. So there are a couple of different ways that that can be done. One way in a formula is to start here and add all of the interest that happens after it. So when we copy that formula up, we're sort of starting at the end, and obviously here in I-45 there's nothing below it. So the only interest payment that's happening in year 20 is related to this remaining $10 million that's outstanding at 379. But in all of the prior periods, we're summing up recursively the interest from all the periods that happen in the later maturing bonds. So that's one way to get there. There is what I think is a slightly more elegant way to get there, which is to use the sum product function in Excel. And what we're going to do here is just lock that final row, 44, so that when we copy this formula down, we get exactly the same results. And at the very end here, we basically get G44 times H44, and that's our 379,000. So that gives us debt service all the way up. And ultimately, what does all this look like? If we put this into a stacked column bar chart, this gives us our debt service. As you can see, our debt service is not level. And the other thing is, if we look at some total columns here, but you can see here our interest component is in the red. Our principal component is $10 million each year. And we've got $200 million worth of principal, which, when we bring that up into our sources and uses, means that we have in our contingency or rounding 98 million more than we need. That number we want to make as close to zero as possible. And again, we're also trying to create a $100 million level debt service structure, 20 years. So we are closing in. We can obviously move this down. Well, no, we're going to want to be in this sort of range. And that gets to 100 million, although then we're $1 million short. So that's not quite right. And we could iterate to find our way to the right amount, although that can be solved for directly. In this case, we're going to use goal seek in Excel to get us to the place where we want to go. Well, let's go ahead and change it right now. So what we want to do is go into goal seek under the what if analysis, and we want to set this cell equal to value 0 by changing this cell. and we see that the answer is $5,050,505.05, which ultimately is not going to work because bonds are sold in $5,000 denominations primarily, and so we're not going to have $505.05. Now, we're getting a little bit ahead of ourselves because the problem here is that, again, what we want is a level principal plus interest payment all the way across the structure. And we do not have that here. We've got something that ultimately is trailing off because principal is being paid off at the same rate, and our interest expense is going down each period because there's less principal outstanding in each year. So how are we going to solve this? How are we going to put a formula in our principal column here that gives us the sizing that we want? We want annual debt service to be $10 million. That's what we've said here. So let's start at the very end. And I know that because I've done this before, but that is one of the tricks in doing these types of structures, is to think about starting at the back with a very simple example where we're basically wanting this debt service to be exactly $10 million. So how do we do that? Well, if we make this just $10 million, then we're off. We're off by $379,000, which not coincidentally is the $379,000 that we have here. So how are we going to make this a formula where we won't be off by this $379,000? Well, the interest rate that we have in this year is $379,000. So one thing that might make sense is to divide our annual debt service that we've targeted by the interest rate in that year. That actually gets us to exactly $10 million. Great. Is that going to work if we copy that formula up here? No. Why? Well, if you take a look, our debt service is exactly over our $10 million by the amount here of the interest in this period. So when we copied this formula up, our 369 here, where we're dividing by 1 plus 369, takes care of the interest that's accruing on this amount going from year 18 to year 19, but it's not taking care of the interest of the bonds that are below it. In this case, the bond that matures in year 20. So what are we going to do about that? Well, let's take a look. What if we did something simple like subtract off the interest expense from the period before it? Well, look at that. That gets us right back to exactly our $10 million amount. And is that formula going to work all the way up and down? Well, let's take a look. It sure does. By this miracle, we have achieved exactly $10 million of debt service in every single period, all the way across the curve, and that is ultimately what we're looking for. However, our principal amount here is $149 million and is in the order of $48 million more than we need. We'll get to that in a second. The first thing we want to take care of here is this fact that these principal amounts are not maturing in standard denominations for bonds. So if we create a denomination here and then went in and said, let's use the truncate function to take our formula divide it by denom, and once it's divided by denom, cut that off, truncate it at 0, and then we'll multiply that by denom again. Now, I had not defined denom, which we'll do now. So now we see that that last amount is $9,630,000, which now is a nice increment of 5,000. We'll copy that up, and now you see that we're under 10 million by exactly a $5,000 increment or less in each year, which is great. It's what we were looking for. What we were not looking for is having this roughly $48 million contingency. And we could have solved for our par amount directly. I won't do that now. What we will do is just use a simple goal seek function that we just used a second ago. And we want to make our contingency in D14 0 by changing our annual debt service. And as close as it can get is 4850, which is within our denomination of 5,000, and that would seem to be fine. Get our double underlines in here. What that means is our deal size was 101,015,000. That gets everyone paid who worked on the deal, the bankers, the lawyers, the financial advisor, as well as gets exactly $100 million into our deposit, and it gets us to level debt service. Okay, that is really what we wanted to cover in this video. It's a very simple way to use a spreadsheet to get a debt service schedule that's level, in this case over 20 years, but you can obviously go ahead and modify that for as many years as you like. And you've got a very flexible environment for structuring some basic bond solutions. Thanks for watching this video. If you've got any other questions or comments, please pick up the phone or shoot us an email. Thanks a lot.